Greetings, ACT Specialist. Commander King here, and I'm looking at this gas tank that I have, and I don't really know what gas is in there, and I'm kind of concerned because I don't want it to explode or be anything dangerous. What I was able to determine after some analysis was that it contained 36.8% nitrogen and 63.2% oxygen by mass, and I know it's some type of gas. All right, so I'm thinking, well, maybe it's, I don't know, it could be, NO or NO2 or maybe N2O, or I don't know, it could be any combination of N and O. It could be N3O, it could be NO100 for all I know, though usually that doesn't happen. All right, so I want to know what are some chemical formulas for this that it could be. And all right, well, the grams don't tell me much because it's not like I can relate those two, but I know if I could find the ratio of the atoms, for example, if I knew that the atoms always occurred in a 1-to-1 ratio, I know it might be NO or N2O2. If I knew it was 1-to-2, and 1 N for every 2 O's, then I know it might be NO2 or N2O4. So it seems like I need the number of atoms, right? But right now I just have the mass. Okay, but I do know the percentage of the mass, so that should be helpful. And what I'm going to do to try to make things a little bit concrete is I'm going to assume that I have 100 grams of this compound. Now, I'm just going to put X and Y because I don't know how many N's, nitrogens, I don't know how many oxygens, so I'm going to assume I have 100 grams. And if that's the case, well then, 36.8 grams out of the 100, because 36.8% must be nitrogen. And on the other hand, 63.2 grams must be oxygen, right? All right, cool. Now I have grams. It's nice, but I can't exactly count the number of grams. But if only there were a way I could convert my grams to the number of atoms or moles, right? Because I know moles are just a lot of atoms. Oh, there is, right? I can use the periodic table. And I know this number here tells me how many grams are in 1 mole of nitrogen. So I can convert from grams to moles. This is totally doable. I want to get to moles of nitrogen. Okay. And I'm going from grams, so I want to get rid of the grams. And I know there are 14.007 grams per 1 mole of nitrogen. This is grams of nitrogen. This is moles of nitrogen. And so if I do that, well, let's see, I get 36.8 divided by 14.007. That gives me 2.63 moles of nitrogen. Okay, so that's a lot of atoms of nitrogen, but it gives me a relative number, 2.63 times 6.02 times 10^23 atoms of nitrogen, but 2.63 moles of nitrogen. That's nice to know. All right, and now I want to figure out how many moles of oxygen I have. Well, if I could do that, if I could go from grams of oxygen to moles of oxygen, that would be nice, right? So let's think about this. Well, if I look at my periodic table, I realize this number tells me how many grams are in 1 mole of oxygen. Well, there are 15.999 grams in 1 mole. 63.2 times 1 divided by 15.99 means that I get about 3.95 moles of oxygen. Okay, so what this is telling me is that for every 2.63 moles of nitrogen, I have 3.95 moles of oxygen. So I'm not done yet because there's all these decimals, and I don't really like decimals. I would like a neater ratio. So I'm going to divide both by the smallest number to get a smaller ratio. So I'm going to divide both by 2.63. If I do that, I get 2.63 divided by 2.63. Well, that's just like 1 mole of nitrogen. And if I do 3.95 divided by 2.63, I get 1.5 moles of oxygen. So in other words, in this compound, for every 1 mole of nitrogen I have, let me use red. For every 1 mole of nitrogen I have 1.5 moles of oxygen, which means I might be tempted to write something like N1, O 1.5, because for every 1, I have 1.5. Now, I've never seen decimals in chemical formulas. Have you seen decimals? No, okay. So I know that can't be right. So what I'm going to do is I'm just going to I'm going to keep the same ratio, and I'm going to multiply everything in here by 2, and that's going to give me N2, O3. And now everything's still in the same ratio, because if I divide 3 by 2, that's 1.5. That's still 1.5 to 1. But now I've got whole numbers. And so I know in this compound there are 2 nitrogens and 3 oxygens, N2O3. And so that is what's in my container here, N2O3. Okay? So I'm glad I figured it out. Now I'm going to go look up to see whether that's a real compound or whether I made that up, or whether I did some mismeasurement. Okay, well, until next time, King out.